Hi, my name is Whitney Willis, and I teach ninth grade environmental science as well as 11th grade physical science. And for the prompt, it kind of asks us to discuss the three EBPs and kind of explain why I selected those particular ones on the behalf of my students. And so the specific evidence-based teaching practices that I kind of really liked was begin lessons with short reviews of previous lessons, and I kind of pulled that from my college experience because one of my professors really did that, kind of did active recall, I suppose, in a way, or spatial, separated type of information recall. And that's kind of like where we just reviewed information, almost everything that we did the previous day on the next day for maybe the first 15 to 20 minutes. And it's just a way to continue on building information as you continue on with the lesson or the units and stuff like that. So I think it's a great way to keep information fresh, and so that by the time they have a cumulative type of assessment with an exam with all the units in it, they won't be shaken up or kind of anxious because they've been practicing or reviewing these questions every single week since the beginning of school. So everything you've been learning from the first week of school, it's being presented the 20th week of school. I also really like providing models such as step-by-step demonstrations or talk out loud to work out the problem. So I recently did a podcast similar to this. So it was like a group of students and they kind of had to explain to me what their topic was. And so we did this in environmental science, and carbon and nitrogen are really important cycles that we need to discuss in class. And so, for example, one of the topics was like, what if we had too much oxygen? Or how did that affect the carbon cycle? And so it was maybe about 3 questions. And so each of the students had to answer the questions individually. And in the video, they had to kind of discuss each question with each other. So it's because everybody had the, different answers for the same question, they were able to have a more robust conversation. And so I think that's a great way of thinking out loud to force them to kind of reinforce information. If you're explaining something to someone else or recording yourself, you should be able to understand what you're saying, or even pulling resources from the internet. You should be able to read and comprehend what you're reading to be able to explain it to someone else. Also, step by step, even though that we're teaching science, is very critical to show them step by step. I kind of learned that today. We were going over cations and anions, and it was some issues of like the plus and minuses because there's a lot of numbers on the periodic table. There's a lot of negatives and positives. It's a lot of equations and things or symbols. It's a lot of symbols on the periodic table, and they just had a little confusion. So the first half I was verbally explaining to them, and they really wasn't grasping the concept. And so I wrote it down, and it was a mind blown shock today because I wrote it out step by step. And so I think it really helps students if they're guided step by step. So it's like I do, we do, you do type of thing. Lastly, engage students in weekly and monthly reviews of past material. Like I said, I do think assessments in a way, like quizzes from a previous unit, would help it refresh them. And even though I'm kind of debating if I want to have it as an exam type of thing that is put in a grade book, but I think engaging them in that same material helps a lot. And that kind of ties into the cross-cutting concepts where there's like a three-dimensional type of learning, and it's just an extra dimension of understanding the concepts. For example, cause and effect. Why does certain thing happen, and what happens once that thing is over?